Right, let's go back to our positive statement. We are looking for those transactions where the existing table employee, so in other words, this is the equivalent of the inner join, and the existing table transaction. So we have these 8 rows, and we're using in. Now there is another format you can use as opposed to in, and that is equal any. So what I'm saying is that I want the transaction number in table transaction to be equal to any of the following: 126, 127, 128, 129. And there we go. Now there is a synonym for any, and this may cause confusion. The synonym is sum, S-O-M-E. So the employee number is equal to sum of the following. That to me doesn't make as much sense. It sounds like it's got to be more than one, but it brings exactly the same results. Now, what if you want the opposite? If I go back to any, because I found that easier. So what if I wanted all of those employee numbers which are in table transaction which are not equal to 126 through 129? Well, let's change this equal to greater than or less than. Will that work? So we seem to have everything else. So if I scroll down, scroll up, and no, it includes employee numbers 126 to 129. So what's happening here? Well, the computer is going along quite nicely and saying, okay, employee number 1, is that not equal to any of 126, 127, 128, 129? That's fine. Employee 2, fine. Then we get to 126. Is that not equal to any of 126, 127, 128, 129? Well, we get to the first one. Is 126 not equal to 126? It is equal, so that's false. Okay, so we can strike that off the list. Is 126 not equal to 127? Well, it isn't equal to 127. So this turns out to be true because 126 is equal to at least, or is not equal to at least one of these. And similarly, when we get to 127, the fact that 127 is equal to this 127, right, that results in false, but because it's not equal to 126, because 127 is not equal to 128, 129, it results as true. So this does not work properly. What we need to do in this situation, where we are comparing one and making it not equal to all the others, is not use any, but to use all. So let's run this and see whether it works. So we scroll down and we can see that 126 through 129 are not there. So this time what it's saying is employee number 1 not equal to all of this lot? Well, it isn't. When we get to 126, is it not equal to all of this lot? Well, it's equal to one of them. So now it resolves as false. 127, is that not equal to all of this lot? Well, it's equal to one of them. So it's false. So it may seem counterintuitive, because you'd, in English, probably want to say is not equal to any of the following. But this time in SQL Server, you have to use all. So it may help you to remember that any or some uses an or condition, and all uses an and condition. So we're saying, is 126 not equal to all of 127, 128, 129, etc.? Well, that's the equivalent of saying, is 126 not equal to 126? And is 126 not equal to 127? And is 126 not equal to that? And so what happens is that the first one resolves as false, and because that resolves as false, all the rest are equal to true, but it equals false. Whereas if we use any, then that is the equivalent of an or. And so we're saying, is 126 not equal to 126? That's right, it's false. No, it is not equal, so we get a false. Was 126 not equal to 127? That's true. And so false or true this time equals true. So that's the difference between any, some, and all. Any and some are exactly the same. All is the opposite. So you can see that all is quite often used with not equal to, or it's used with less than and greater than. It's just generally not used with equals, because 126 can't be equal to 126 and 127 and 128 and 129, whereas 126 can be equal to any of the following: 126 and 127, 128 or 129. And you don't just have to use equals or is not equal to. You can also use, say, less than or equals to. So let's have a think about what's going to happen. It's going to, because I'm using any, look into here and say 126, 127, 128, 129. And essentially it's going to say which is the highest of them. 129. Because it's going to allow any numbers which are, and I'm going to take 0 as the base though, because we're talking integers, it could be minus 2 billion, but so anything up to 126, or anything up to 127, or anything up to 128, or anything up to 129. So we could start at minus 2 billion. You could say 0 if you want to, but it does go from minus 2 billion. It just so happens that our employee numbers start at 0. So it will go from minus 2 billion, let's use that for accuracy, to 126. And it will also go from minus 2 billion to 127, 128, 129. So whether it fulfills any of those criteria, it will be true. So let's have a look at the answer, and so we can see it goes from 1 all the way to 129. Now, if we did an all, then this or gets changed to an and. So any up to 126, and it's also got to be any up to 127, and it's also got to be anything up to 128, and it's also got to be anything up to 129. So if you think about it, the equivalent of the all, if I was to sum it up in one statement, would be any up to 129. It would be the loosest of all of the conditions, whereas that's for any, whereas for all it would be any up to 126. But so anything, let's call that, because I don't like to use the word any, because we've got any already. So what all does is tighten the conditions. It's got to fulfill every single one of them. So that's the equivalent of an and. Whereas any does the loosest of the conditions. So if I run this with an any clause, is less than any of the following, and go right to the bottom, you'll see that it goes all the way up to 129. Whereas if I change this with an all, then you'll see that it only goes up to 126. So that is any, also known as some, and all.